Assalamualaikum warahmatullahi wabarakatuh. I be to Dr. MARYAM binti HUSIN. I am Muhammad Huzaifah bin Yaacob from AS245 to S, and today I will present about my presentation in tray dryer experiment. There are different types of dryers available in market, like tray dryer, rotary drum dryer, fluidized bed dryer, cabinet tray dryer, screw conveyor dryer, and vacuum dryer. So this is the picture of tray dryer, or even we can call it cabinet tray dryer. The theory of this dryer. Tray dryer is widely used for material drying in pharmaceutical manufacturing or even in the industry. The basic working principle of this incredible machine is the continuous circulation of hot air in the system. In the tray dryer, moisture is removed from the solids that are placed in the tray by a forced convectional heating by reduction of water content about 15 to 20% of moisture, and it is the simplest form of dryer. Either we can use batch dryer or continuous dryer. The principle of tray dryer. In tray dryers, either batch or continuous, a hot air steam passes over the surface of the product, provide heat for evaporation process, and act as a medium which water vapor is carried away from the food. Many mechanisms come into play in controlling the rate of drying. During the initial process of drying, the drying rate will constant and water evaporates freely away from the surface. In the late period of drying, water must move from interior of the product to the surface. This may happen due to liquid diffusion, capillary movement, surface diffusion, gaseous diffusion, or may be related to product shrinkage. Drying curves can be determined for a food product in each dryer and drying conditions, and these will usually show characteristic drying periods, including constant rate drying and falling rate drying periods. For experiments, we will use the sand as sample and solids to determine drying rate plots and using the result to derive information to predict drying times. Here is the result we got. The time we use, the initial time is 0 minute until 19 minutes, which is 1 hour to 13 minutes, and the initial mass of wet sand is 1.009 kilogram, and we can see it reduced until 0.705 in 19 minutes. For the moisture content, we can hear that 0.4313 volume until 0 in the last minute, and also for the drying rate from 0.00695 per minute until 0 per minute. Then we plot the graph, the moisture content versus time. As we can see that the time increase, the moisture content will be decreased. This is the second plotted graph, which is drying rate versus moisture content. As we can see that the moisture content increase, the drying rate will be increased also. And the first 9 point is the falling rate, and the third last point is the drying rate is start to be a constant. As a discussion, the previous graph show that drying rate and moisture content are affected by the velocity of the air in the system. Although the speed of fan is set constant at the lower speed, but based on the results, there are changes in velocity present. And as we can see that as the time increase, the moisture content will be decreased. This is owing to the water from the wet sand is slowly start evaporate to the air until there is no water in the end. And at the second plotted graph, we can see that As the moisture content increase, the drying rate will be increased too, because by virtue of the drying rate is highly depending with moisture content in the sand. And we can analyze that the result from the experiment is acceptable with the theoretical one, and the moisture content is fully removed until the end, and the drying curve shows the same pattern as the theoretical one. As a conclusion, we can say that drying rate and moisture content are highly depending on each other based on the plotted graph and calculation that we made. The objective of this experiment is to determine drying rate and moisture content of the sample to removal of water has been achieved at the last. So that's all from me. Thank you.